Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today, we are going to learn how you can use Amazon Redshift Data API for ETL purpose. Well, if you look into Amazon Redshift Data API, it is generally not used for ETL purposes, but recently when I was working with one of my customers, I saw them using Redshift SQL statement for the ETL purpose. And then they were trying to use Redshift Data APIs for the orchestration. And I found it very interesting, and I thought, why not share this experience back with you guys, because actually you can use this method in a certain scenario which fits your needs. So let's see how this method works, when it is good to use this method, when not. And of course, we have a demo towards the end of the presentation to show the things working. So let's get started. Now, if you look at an typical ETL pipeline, I have talked this typical ETL pipeline many times, but just one more time for the sake of setting up the context, you will have data sources, and from data sources, you bring data to the data platform. You keep your data in three stages, generally in three stages: raw, cleansed, and curated. Curated is where your data is ready for consumption for your end users, for the use cases. Cleansed is where the data is cleansed, all kind of data formatting issues, missing data, those kind of cleansing tasks are performed on your data. And the raw is where the first time data ingested and the data is kept as a immutable data in the raw stage. So generally people keep raw and cleansed both in Amazon S3 bucket, but when it comes to curated, they can decide to keep curated anywhere, but generally people keep data into S3 or Redshift. And today I'm going to talk about if I want to move data from S3 to Redshift, how I can use SQL statements within Amazon Redshift along with data APIs to orchestrate this whole ETL pipeline. So let's discuss that out. So if you're trying to bring data from S3 to Redshift, and again, when I'm trying to bring data from S3 to Redshift, I am cataloging my data into S3 because, again, I told you many times, and I'm no shame in repeating one more time, that if you are bringing any kind of data into your data platform, catalog it, because once you catalog it, your data is searchable and discoverable. If you don't catalog your data is kind of a lost data because there is no way a user can know what data is there in the platform unless you have cataloged it. Okay, so cataloging is important. So you bring your data to S3, you catalog it, and then you want to move to Redshift. So let's, for the sake of completion, try to understand what different options you have. So of course, you can use AWS Glue job to move data from S3 to Redshift. And if you look into my tutorial, you will find definitely a tutorial talking about using Amazon Glue job to move data from S3 to Redshift. You can use Amazon EMR Step, so you can configure a step inside Amazon EMR which can bring data from S3 to Redshift. Of course, you can do that. You can use Redshift Copy command, of course. Yeah, I mean, if you simply want to do a simple copy and don't want to perform any kind of transformation, then you can simply run Amazon Redshift Copy command to copy data from S3 to Redshift in a very performant way. Okay. And the fourth option is actually you can use a combination of different capabilities like Amazon Redshift, SQL statements within Redshift, Amazon Redshift API, and Amazon Event Bridge to orchestrate this whole moving data from S3 to Redshift. So this is the option I want to discuss today. And as I told you earlier that I saw one of the customers using this option, and I found it really very interesting, and in fact fitting in certain cases, and I thought, why not we share how it can be done so that you can make use of this approach if your requirements are also fit into this kind of design. So let's try to first understand how exactly this whole thing works, because then I can go and elaborate on individual pieces of the design, but let's try to paint the big picture and try to understand how this whole system works. So generally, so you have Amazon S3 bucket, and again, this is what I'm showing you. Example today is something I'm going to also show you in demo. So I have got in S3 bucket where suppose there are two types of data I have. One is my sales data and one is my customers data. And then I have used AWS crawler to catalog this data. As I told you, cataloging is very important. So I use AWS Glue crawler to catalog this data, and I created two catalog tables, sales and customers, in DojoDB database. Simple. And all these things, I have covered in many other topics, many other like videos if you don't understand how cataloging works and those kind of things. And then I tried a technique called Redshift Spectrum, or a feature called Redshift Spectrum within Amazon, which you can use to configure your catalog table as external schema within Amazon Redshift database. So now this is Amazon Redshift database purview, and under that you can create external schema. And in this case, since we had sales and customers as my two tables under DojoDB database, catalog database, so we created an external schema called DojoDB schema. And under that, we created sales and customers as two external tables. So if you don't understand what Amazon Redshift Spectrum is, I have a separate video talking about what exactly Spectrum is and when people use Spectrum and how you can configure it and use it. Okay. So you configure your catalog as external schema in Amazon Redshift database. And then suppose with these two tables, external tables like sales and customers, which actually represent data sitting inside S3 bucket. Data is not stored in Redshift, but data is stored in S3 bucket. It's only available through this external schema for the query. Suppose you want to create in local schema, local public schema, three tables. And one table is customer sales, which talks about the total sales per customer. Then we have customer contacts, which talks about for each customer, what is the contact first name and last name. And then we have customer cities, which talks about how many customers are in every city. Yeah. So suppose using these two tables, those two external tables, I want to create these three local tables. So in order to do so, actually to move data from these external tables to, or in a sense, external tables, since external table is not storing any data, actually in order to move data from S3 bucket using this external table to this local table, you perform certain SQL statements. So I run one SQL statement which is going to populate my customer sales. Then I run second SQL statement which is going to populate my customer contacts. And then I have third SQL statement which is going to populate customers' cities. So you can see here, this portion is actually a ETL you're running. So you're kind of running an ETL over here where your SQL 1, SQL 2, SQL 3, these three SQL jobs run in a sequence in order to populate these three tables. And today we are going to talk about how you can configure this SQL, how you can configure this SQL statements as an ETL using data APIs and run it in certain sequence. Okay. So the process works pretty straightforward. You have Amazon S3 bucket, which you catalog it. Then you use Redshift Spectrum method to create an external schema for that data in the Redshift database. And then when you want to populate, say, some local tables, then you use, like for instance, using these 3 SQL statements to populate three tables, and these SQL statements you can orchestrate. And how do you orchestrate? That's what I'm going to talk about. So that's how exactly it works. And let's dig into some of the individual design details or configuration details. So before we go to the design details, when I'm trying to create an orchestration like this, because to be honest, this orchestration I can create inside EMR, I can create inside glue job, I can do at many places. So, but here in this case, we are using SQL statements within Amazon Redshift in order to orchestrate these 3 SQL statements to populate 3 tables. So what are the pros and cons of that? So that you know what is good and what is not so good, and accordingly you can make use of this method depending on what your requirements are. So let's talk about the pros first. So the good part is that generally I have seen is that people who are using Redshift for a very long time, they don't understand Python and PySpark, but they understand query very well. So this method you can use with a team which has a lot of knowledge of SQL, but they're not so good with Python and PySpark. So yeah, I mean, good SQL knowledge is good enough to configure this kind of ETL. You don't have to worry about other ETL programming languages or methods. This approach also provides very good performance because it's like querying external schema tables and populating the local tables. So it's very much, you can really achieve a good level of parallelism in this case, and you can really achieve a very good performance here. So these are the good things in my opinion. You get a good performance, and if you don't have a knowledge beyond SQL, you can still configure this kind of ETL. Okay. Now, if you try to understand the cons part of it, and the first thing which I find which is a drawback of this approach is that when you're writing this ETL statement or running these ETL statements, actually you are consuming the Redshift compute and memory. Keep this in mind. So you are utilizing Redshift capacity. Now, Redshift capacity is not only for ETL. Redshift capacity is used for data processing, it's for data query and those kind of things. And now you're also giving a job of ETL to the Redshift. So in a way, you are adding load on Redshift in this method. But what many customers do, and I have seen like in this particular case, is where people try to use the non-peak hours for ETL things. So during peak hours, they keep Redshift just for the query purposes, for different type of analysis and queries people are running on the Redshift. But when the non-peak hour comes, then at that time Redshift capacity is underutilized, and at that time people use this that capacity for the ETL purpose. So keep this in mind that if your ETL requirement is such that you're going to use ETL in your peak time, then in a way you are overloading your Redshift compute capacity. That means you might have to go for a bigger cluster sometime soon if you don't get enough performance. However, if your ETL is something which runs in the non-peak hour and can be finished in non-peak hour, then yeah, I mean, it's a good approach in the sense that your Redshift cluster was anyway sitting idle there, and now you can use that idle time to run your ETL. Yeah, and it gives good performance. I told you earlier. The second drawback I see that in this case, since you're using SQL statement, then your data transformation capability is very much limited to what SQL can do. Yeah, so whatever transformation you can do in SQL, only that transformation you can do, nothing beyond it. So that's the limitation you should be aware of. So if you think that, yeah, I can write all my transformation in SQL only, of course, this is a good enough approach. You can use it as long as you can take care of the capacity part. But if you think that, no, I have very complex transformation and SQL alone cannot perform all those transformations, at least not easily, then of course, then I think you should be thinking about some other way of writing ETL, whether you're using glue job, EMR, any other methods. Okay. So keep these two pros and cons in mind. They are not very complex, but it's very important you understand. So moving on. So how do we build such solution? What are the building blocks? And the first building block and the most important building block here is Redshift Spectrum. And I'm not going to speak a lot about Redshift Spectrum, but Redshift Spectrum is a mechanism using which you can actually create federated table or kind of create an external schema within Amazon Redshift. And in this case, actually, you're using an external schema which is actually basically providing your method to query data stored in S3 right from the Redshift. So I have another tutorial where I talk about Redshift Spectrum in greater detail. So please watch that if you don't, if you're not aware of Redshift Spectrum. But first building block and the most important building block, in my opinion, is that you should be, you have to configure Redshift Spectrum. You have to use Redshift Spectrum to configure your S3 data as an external schema within Amazon Redshift database. Yeah. Okay. So let's move on. So where do I keep these SQL statements? Well, it's not necessary. Well, you can run the SQL statement in your ETL as it is, but sometimes SQL statements are very large, then it becomes very hard to manage. So it is recommended, though it's not mandatory, that you convert each of your SQL statement as stored procedure. It also provides better performance that way. So convert each of the SQL statement you want to use in your ETL into stored procedures so that those stored procedures can be called in the ETL configuration to execute your ETL operation end to end. Again, it's not mandatory, but generally I found it is more manageable and easy to configure, easy to I say it's more manageable, let's take it that way, if you're using stored procedure, plus you of course get a better performance. So convert your SQL statement into stored procedures within Redshift. Moving on. So how do we run this SQL? So basically what you're trying to do is that you are trying to run a SQL in Amazon Redshift and you want to orchestrate it. Now this orchestration is done by Lambda Function. So basically what this Lambda Function does is that it uses Redshift Data API to call this stored procedure or SQL statement in the Redshift in certain sequence to perform the orchestration. So the bottom line is the SQL statements or stored procedures are run by Lambda Function using Redshift Data API. And since AWS Lambda needs to know the login and password or credentials of the Redshift cluster in order to execute the Redshift Data APIs, those credentials are stored into AWS Secrets Manager, and then AWS Lambda simply fetches the Redshift API, Redshift credentials from the Secrets Manager to execute the SQL statement on the Amazon Redshift cluster using Data API. So this is the code snippet of how it works actually. So for instance, I'm creating I'm using Python as example here. So I'm creating a Boto3 client in Python for Redshift data. Then I'm providing my cluster name as parameter, database name as parameter, and I'm also providing my secrets manager's secrets ARN so that Lambda function can simply use this ARN to fetch the login and password for the Amazon Redshift cluster. And then I'm simply saying this Redshift data client dot execute statement, and we simply pass cluster ID, database name, secrets name, and SQL statement. So this is the SQL statement. And this SQL statement could be simple SQL statement and can also be a stored procedure. So you provide what SQL statement you want to run. You provide that SQL statement over here. Each of the statement you're running, you can also provide a name. So I mean, it's not mandatory parameter that you provide a statement a name, but since you are doing an orchestration here, providing a name is a good idea because that way you know that this statement is finished, the next statement is coming, the next statement is coming. So you do provide SQL statement here, and then you provide a name for that statement. And then you also configure with events method. So later I'm going to show that we are going to use event bridge for the orchestration. So when you use this with event equal to true, then what happens when the execution status changes for this statement, you event bridge will get the events for that, and those events can then be used for the orchestration purpose. So it's pretty straightforward. I am simply doing the execute statement on this cluster, on this database, using this credential. This is the SQL statement I want to run. This is the name of the SQL statement I want to give, just for the, so that every statement I'm running, I'm giving a name. And then with events equal to true, you're saying that when this SQL statement's execution status changes, because you're running an ETL, and your ETL SQL statement can take minutes to hours to complete. And in that case, with events equal to true, when the SQL statement execution status changes, event bridge will receive an event for that, and those events you can use for the orchestration purposes. And we are going to see all this configuration very soon in our demo. So moving on. So how does this whole orchestration is going to work? It now comes down to that. So here I have got an Amazon S3 bucket where I'm using a glue job to populate data into Amazon S3 bucket. So assume this is my cleansed data bucket where my AWS glue job is writing data to the S3 bucket. When the glue job finish writing the data, it bubbles up an event to event bridge. And for that, in event bridge, you have to create a rule for glue job status change. So you have to create a rule to track the glue job status change. And when you do that, when the glue job finishes the execution, it bubble up an event to event bridge saying that, hey, glue job has finished writing data to the S3 bucket. And at that point of time, actually this event bridge event bus can trigger a Lambda function upon getting to know that my glue job has finished. And what this Lambda function does is that it's going to simply call the first stored procedure called SQL1. So it executes the first stored procedure. Now, when the stored procedure finishes the execution, or SQL statement finishes the statement, your Redshift is going to bubble up the event because your event bridge is also configured for another rule, and that rule is Redshift data state change. So if the SQL statement is running, and if the SQL statement execution status changes, my Redshift database is going to bubble up the event to event bridge. So my Lambda function is calling the SQL1 statement. Then when the SQL1 statement finishes, the Redshift cluster passes a notification event back to event bridge saying that, yeah, this SQL statement is done. And here the SQL statement name is important because then it tells this SQL statement name is done. So that way, by no name, you know which SQL statements have finished. So now Lambda come to know that, yeah, and then when it comes over here, event bridge again calls the Lambda function, and now Lambda function knows that my statement 1 has finished. So it's going to actually start the statement number 2. So it's going to start the statement number 2. And when the statement number 2 finishes, that also tells back to the event bridge that, yeah, I am done. And then at that point of time, Lambda will say, okay, fair enough, then I'm going to run this SQL statement number 3. And then similarly, Lambda Redshift will pass the event back to the event bridge when the SQL statement number 3 finishes. So that's how this whole orchestration works. It is initialized by some external event. In this case, I'm taking the example of a glue job which has started this whole process. And then your Lambda function is triggered. It will call the first statement, then will come to know that first statement is finished. Then it will call the second statement, then it will come to know the second statement is finished. Then it will call the third statement, and then it will finish the third. It will come to know about the status of the third statement. And that's how Lambda function is going to orchestrate. Now in this case, Lambda function is simply starting the execution. It's not waiting for execution to finish. So it's simply kick start the execute statement, and then it will wait for this event to bubble up, and then it will come to know that which of the SQL statement has finished, and it will call the next SQL statement. Now the question comes is that how does Lambda function know that once this, or even how does the event bridge know that once my glue job has finished, I need to call this Lambda function, and then this Lambda function is going to call the SQL 1, and how my Lambda function will know that after SQL 1 it has to execute SQL 2, and after SQL 2 it has to execute SQL 3. So somewhere this configuration has to be there which says that which statement to call the next once the previous statement has finished. And that information actually you can store into a DynamoDB table. So you can create a 4-column tables like this, where you have your source, target, target type, and target SQL. So for instance, if you look example, this says once my job 1 finishes, start statement 1, which is a SQL type, and this is the SQL statement. So remember, I told you that use stored procedure. Now if you don't use stored procedure, you have to provide your whole SQL statement over here. And Lambda function and DynamoDB table has a limit of, I think, if I'm not wrong, 256 KB per row. I could be wrong, but please correct me if I'm wrong. So it has a limit per row. So I don't want my SQL statement to very big, because otherwise it could be limiting to me. And that's why I told you that you might want to put your SQL statements into stored procedure, so that you can simply call stored procedure over here. So what's saying is that what this configuration is saying, this Lambda function, is that when job 1 finishes, start statement 1, which is of a SQL type, and then this is the stored procedure. When statement 1 finishes, run statement 2. When statement 2 finishes, run statement 3, and these are their respective SQL statements. And when statement 3 finishes, that's the end of my ETL, and then you simply say none, none, none. That means, hey, I'm done. I don't need to run anything else. So again, I have put here a target type because right now it is SQL only, but you might get a scenario where you want to run statement 1, then you want to run the job 2, then you want to run crawler 3. In that case, actually this whole configuration can be extended to run things beyond SQL. But right now in the example, I'm focusing on orchestrating only the SQL statement. But keep this in mind, with this design, actually you can orchestrate SQLs, glue job, many other things. So moving on. So how does this Lambda function look like? And this Lambda function is pretty straightforward. It's a simple and single Lambda function which is taking care of the whole orchestration. So this is how the code of the Lambda function look like actually. So you hook into 2 events. One is your event bridge has hooked into 2 events, your glue job status change, your Redshift data statement status change. And what you're doing here is that you first trying to identify from which of the events this Lambda function has been called. And if it is job event, then you fetch the job name. And if it is the SQL statement event, then you fetch the statement name. Because of course, once you know the statement name, then only you know what next statement to call. Then I'm also fetching the state of the event, whether the state is succeeded or failed. If failed, of course, you want to do some kind of error handling, and in this case, I'm not doing it. I'm just taking the happy path. Now we create a DynamoDB table, and then we simply make query to this RS statement, the table I showed you earlier. And I'm saying that for this source, for this job or this statement, where source is source, tell me the target SQL, and target type. So I fetch my target SQL, and target type. And this code, by the way, I am providing in the code snippet in the link below. So you can copy paste from there if you want to make changes to it or make use of it for your own test. And after that, then I'm simply checking if the target type is SQL and state is finished or succeeded. Then in that case, you simply create a Redshift client, Redshift data client, provide the cluster ID, database secret ID, and simply call the execute statement. Done. Yeah. And here I provide my target SQL and target statement name. And then if it is a job type target, and again the state is finished or succeeded, then simply start the glue job. Nothing more than that. So it's pretty straightforward code, which is simply fetching the information from DynamoDB to determine which job or statement has finished the execution and what is my next target SQL or target job, and simply execute that. So as straightforward. So this is the code which is orchestrating the whole thing. So this example I showed, it's time to see the demo and things in working. So the example I talked about, I'm going to show over here. The way it will work is that I will run a dummy glue job. Literally, the glue job is doing literally nothing. It just running over there. But when this dummy glue job runs actually, but in actual scenario, of course, you don't want to do a dummy glue job. You can use this glue job to actually write data to S3, and then you want to run the rest of the orchestration to fetch data from S3 and populate into Redshift. But in this case, I have created a dummy job. When this glue job finishes, this whole ETL process starts, which runs SQL statement 1, 2, 3 to populate these 3 tables from these 2 external schema tables. So that's what we're going to see in the demo. So let's get started. So here we go. You can see over here, I have got my customers and sales data into an S3 bucket. And then what I have done is that I have catalog the table. I have cataloged the tables, so sales table and customer tables. Let's have a quick look at these 2 tables. These 2 tables. So if I view data, yes, please. So you can see here, this is how my my sales tables look like. Okay, so it's pretty straightforward and simple table. And this is how my customers tables will look like. If I run the customers table, you can see my customers table over here. So these are 2 data sets, CSV data sets I have in my S3 bucket, which I have simply cataloged. Then I go to Redshift. So I have got a Redshift cluster. And in that Redshift cluster, let me show you the details. So this is the new, by the way, this is the new query editor, which I really like it. So in this Redshift cluster, actually, you can see here that I have used Redshift Spectrum to configure DynamoDB underscore schema, and which has got 2 external tables, customers and sales. So actually I can come here and say, okay, I want to see the DynamoDB underscore schema dot sales. Okay, limit 10. If I run that, I should be able to see the table data, and this table data actually is coming from S3 bucket. This data is not stored. So the same data we saw in Athena, which is coming from S3 bucket, the same data you see here as well. This data is also coming from S3 and available within Redshift database through external schema using Redshift Spectrum. Again, if you are not aware of Redshift Spectrum, you might want to check my other video. So let's minimize this one, and then these are 3 local tables I've created. So I told you that I have customer sales, customer contacts, customer cities, and what I'm doing is that I'm simply populating these 3 tables from these 2 tables, contacts and sales I have in my external schema. And in order to populate these 3 tables, I have got 3 functions created. So for instance, if I open this one, okay, can I see the procedures, sorry. So I've created 3 procedures, not functions. And the first procedure is fill customer cities, where I'm simply providing a customer count per city, actually. So city and the customer count there. And I'm simply populating that into customer cities. Similarly, I have created also customer contacts and customer sales as stored procedures, which you can use to populate customer contact. So this is the procedure for customer contact, and this is the procedure for customer sales. So I have already created 3 procedures. Now here I have got my Lambda function configured. So this was again, I'm going to provide all this SQL statement in case you want to use it in some way. Now here is my Lambda function, which does all the execution, and this is the same code I showed you earlier in the example, and this code anyway I am providing you in the description through a link in description box. And I'm doing some printing job here, because I want to print my source, I want to print my state, I want to print my target, so that I can show you the whole execution flow when I run the demo. So I have added some print statement, otherwise it's all good, looks nice to me. Few things to know: I have added few things into configuration in order to avoid any hard coding. So you can see here the database name I have provided into the environment variable of the Lambda function. The cluster name I have provided there, and secret ARN, the secrets manager's secret, which is storing the Redshift credentials, that also I have provided over here. And in the code, you can see here is that we are using this, we are fetching the value from these environments variable over here, like in these 3 statements. Okay, fair enough. So I have opened a page for this Redshift function, this Lambda function to capture the log, because I really want to see the whole execution through the log. So I have emptied the log so that when I trigger the workflow, it will show you the new log created. Then I have created an RS statements DynamoDB table, where I have simply configured my sequence of execution. And this is the same table I showed you in my presentation. I have just created in DynamoDB table. Then here is my secrets manager, which is simply keeping my Redshift credentials stored, so nothing much to worry. And then we have got here, here we go. So now I have got event bridge, where I have configured 2 rules. And one rule is a job handler rule, which will simply handle the job status change, and other is RS workflow rule, which is simply taking care of the Redshift Data API call status change. So let's go and see each of these 2 rules in detail. So first is the job handler rule, which is responsible for actually tracking the job status change. So you can see here it is looking for glue job status change. And when this event is bubbled, so whenever the glue job status changes, it will raise an event over here, and then when the event is raised, this RS workflow function, our Lambda function, gets called. And you have seen the code, how it handles and orchestrate the next statement or next job. Similarly, I have got another rule, which is RS workflow rule, and in this case it is tracking a Redshift data statement status change. And then whenever the when the Redshift when the SQL statements is run by Redshift Data API, and when the execution status changes, it will raise an event to the event bridge bus using this rule. And when, of course, the event is bubbled, it will call the same Lambda function I showed you earlier. So these are the different set of configuration I have done in order to make this whole workflow work. Now what I need to do is simply start the glue job. So let me show you the glue job. And as I told you, so if I go back to my presentation here, so you can see here, I will start the glue job, which is a dummy glue job, and it's going to simply start my ETL process. So that's what I'm going to show you now. I'm going to run this job 1. And as per this orchestration, when the job 1 finishes, it's going to run the statement 1. When statement 1 finishes, statement 2. When statement 2 finishes, statement 3. When statement 3 finishes, the end of the ETL. And these are 3 different statements or stored procedures is going to execute. So let me go back to glue job, and I told you this is a dummy glue job. It does literally nothing. So you can see here in the code I have written here print dummy job 1 completed. So literally it's doing nothing over here. It's simply I'm using for demo purpose to start the whole ETL orchestration. But in actual implementation, you can use a glue job like this to write data to S3 bucket in cleanse layer, and then you want to run this whole ETL process inside SQL statement using SQL statement to bring the data from the S3 bucket to the glue local table. So let's start this glue job, and that should start the whole ETL process. So let me run the job. And I started the job. Now, job has started executing actually, and what I'm going to do is that I'm going to sit here in my in my Lambda function log, because very soon I'm expecting log getting populated over here, and when when my whole workflow has finished execution, I will show you this log detail to show you in what sequence the statements were called, and we can also go and verify the data in Redshift Spectrum table as well. So let's wait for this whole workflow to finish, and then I will show you the outcome after that. Okay, so it has finished the execution. And it didn't take very long actually. So now let me show you first the logs, so you understand in what sequence the whole workflow has finished. And then I will show you the results in the Redshift database as well. So if I go to my log, my Lambda function log, you can see here my job 1 succeeded, and then it called statement 1, which basically was executing this particular stored procedure of SQL type. Then when my statement 1, and then that's where the first time Lambda function was called, and it made note of the whole request details. Then again next time the Lambda function was called, this time it came to know that statement 1 has finished, and it says okay, now I have to call statement 2. And then when statement 2 finished, it said okay, I need to now start statement number 3, which is this particular SQL function or SQL procedure. And then when my statement 3 finished, then I got a notification none, none, none. That means it's end of the workflow. You don't need to do anything further. So the whole ETL process stopped. So you can see here in log, it has simply executed the SQL statements in the sequence we wanted for our requirement. Now, if I go to Redshift here, and simply if I close this thing here and say, you know what, I want to now select star from public customer cities, run it, I should get the answer. Yeah, you can see here it's showing me the customer count per city. Similarly, I can also see my customer sales. So my local table are now populated from the data in S3 bucket. And that's pretty much was the purpose of this demo, to show you that how you can use Redshift Data API with Redshift Spectrum and a little bit of Lambda and a little bit Event Bridge to create literally an ETL using your SQL statement to populate your Redshift local tables using data in the S3 bucket. So that was all for this video, guys. Hope you like this video, and if you like, please click on the like button. Please subscribe to my channel. I always look forward to your feedback, whether it is for request for new content or anything wrong I said or misrepresented and you want to correct me, or if you want to discuss any of the topic I talked about, any of design questions you have and you want to bounce your approach with me, feel free to reach out to me through the comment section in my YouTube channel. I look forward to your comments to improve my content. I promise to come back again in a week's time with another such tutorial, such video. In the meantime, please stay safe and have a nice day. Bye-bye.